Hi, last time we talked about a powerful method called the leaf method. This is used for finding prime factorizations, the greatest common factor, the least common denominator, square roots, and simplification. We did last time prime factorization, and we learned how to find the prime factorization of a couple of numbers, 100, 36, and 48. And if you need to find out more about how to find more prime factorization numbers, either you write down on the bottom of the YouTube video some comments and I'll make more videos about it. But today I wanted to continue on with finding the greatest common factors of numbers. Well, last time we talked about 136. Now, we wanted to look at the following concept. Between 136, we want to find out numbers that are going to be the same one-to-one. So, for example, the 2 is the same thing as this 2 here. So we're going to circle one-to-one the numbers that are the same on both of them. Here, the 2 is also the same as this 2. So we circle it. Now, what's going to happen is you're going to multiply, and one of those, the two numbers that are circled. So this is 2 times 2 is 4. Therefore, the greatest common factor between 136 is 4. Let me give you an additional example. Let's say between 36 and 48. I want to find out the greatest common factor between them. So, since we already did the leaf method, you only need to look at the right-hand side to find numbers that are the same one-to-one. So this 2 is the same thing as this 2. What other numbers are the same? Well, this 2 could go with any of these guys. So I'm going to choose this just to vary, right? 2 with that 2. Do you see any other numbers that are the same? Okay, we have 1, 3 with that 3. Okay, anything else? Well, that 3 doesn't have an additional 3, so therefore it stays like this. So now we're going to multiply one of them on one side, all the numbers. So 2 times 2 is 4, 4 times 3 is 12. Therefore, the greatest common factor between 36 and 48 is 12. That covers the greatest common factors. Now, let's do a couple more things, more examples, such as finding simplification of things. So if I were to ask you, I want you to simplify 36 and 100. How would you be able to do that? Well, the same thing again. You look at the leaf method. After you have completed the leaf method, you're going to look at a couple of things, such as you're going to, instead of circling, you're going to cancel these numbers out, one-to-one. Do you see a 5 here? No. A 5 here? No. A 2? Yes. A 2 with a 2. Okay, so instead of circling, you're going to cancel this 2 with that 2. How about this 2? You're going to cancel it with this 2. Now, whatever numbers are left are the numbers that you're going to multiply. 5 times 5, that's 25. So 100 just became 25. How about 36? The numbers that remain are 3 and 3. You're going to multiply 3 times 3, that becomes 9. That becomes 9. So, if I simplify 36 over 100, my answer is 9 over 25. What I like about the leaf method is that this number at the very end is in lowest terms. You don't need to look for further numbers because it's in lowest terms. Now, let's try 36 and 48. Let's say if I were to ask, 36 divided by 48 is the same thing as what? Now, the same concept goes again. You're going to scratch this time. We're going to scratch the numbers that are the same, and you're going to multiply the factors that are left. Alright, let's see. Between 36 and 48, what are the factors that are the same? Well, this 2 is the same thing as that 2. That 2 is the same thing as that 2. That 3 is the same thing as that 3. Right? And what are the numbers that are left for the 36? That became a 3. A 3 and there's nothing left, so 3 times 1 is 3. And the 48, the numbers that are left are 2 and 2, and you need to multiply them. So it becomes 2 times 2, that becomes a 4. So 3/4. So 36 over 48 became 3 over 4. And then if they were to ask you what 48 over 36 is, since you already know what this is, 48 becomes a 4 and 36 becomes a 3. So either way, you know how to simplify things to its lowest terms using the leaf method. Next time, we're going to talk about the least common denominator, square roots, and simplification.